So far, we placed ice into this pot. We turn the stove on, so we're adding heat to the system, and we're going to see what happens over time. So let me kind of walk you guys over here so you could see the ice in the pot. Okay. So far, write down your observations of what you see happening. Okay. Now, I have a special type of stove. My stove is an induction stove. So it works within a matter of 30 seconds, no matter what you put on it. The name of the assignment, Naomi, is Kinetic Theory Demo with Miss Hutchins. Volunteer, Sanaya, I'm going to allow you to unmute yourself so that you can tell me what you're observing. Sanaya Pearson.
Okay. I see that the ice is melting, and that is when it's transitioning from a solid to a liquid.
There we go. Perfect. Did everyone who agrees with her, give me a thumbs up. If you disagree and you want to build upon what she said, please type in the chat room so that I can call on you. If someone respectfully disagrees, or if people agree and want to build upon what she said, please log into the chat room and let me know if you want to go. So Seth, go ahead, Seth. Build upon what Sanaya has said.
So, I think what I observed is that, yes, it was melting. It also kind of looked like it was boiling a bit.
It looked like it was boiling a bit. Okay. And I see that Darwin also wants to add in. Go ahead, Darwin.
Hi, Miss Hutchins. I
Hi.
agree with Seth and Tanaya because, like, the ice, when hotness is added to coldness, the hotness will melt the ice and it will start transforming into a liquid, from a solid to a liquid.
Okay. And I see that Tahira would like to add on. Okay, I see that Chase would like to add on.
I agree with Sanaya and Darwin, and it's also showing the transition of the three states of matter, which are solid, liquid, and gas.
All right. And one more person, Genesis Pinson. Speak up, sweetie. We can barely hear you.
I would like to modify what everyone said. I think the ice, when it will melt into water, and when the water is heated, it will start.
All right. So now I'm going to show you, we're going into a new phase in this pot. I'm going to show you what's happening next. So you're following along inside of the document and you're typing your observations, okay? Did you all notice now? Type your answers. Oh, someone said do not drop it. I won't. Type your answers. What do you see? It is boiling a lot. Okay, something else is happening now. Uh-oh, what is that? And then there's this substance escaping the pot. I don't know if you guys can see it. There's a substance escaping the pot. Let me bring you in a little closer. Okay. What do you notice about someone said gas, someone said evaporation. All right, yeah, let's not try to say the answers. Okay, so let me hear from, okay, Diana, we're not going to put an egg in there. Let's not play on the chat room. This is serious. I don't know who Tori XX Blade is, so if that person can type their name in, that would be great. Japney, can you tell me what that substance is called that was produced, that was coming from the pot as the water began to boil? Do you know how to unmute yourself? Okay, what is that substance called that's coming from the pot as the water boils? What was that substance called?
Something called hot water.
So the water is hot, it's boiling right now, see? But there is something leaving the pot as the water is boiling. It's kind of clouding up my camera right now. Somebody want to help her out?
Can I help Jackie?
Who said that?
Me, Darwin.
Darwin, go on.
The new substance that's created, it's called steam.
It is called steam. Very good. All right. So I'm going to share my screen again with you all to show you where we should be in the document right now. So you should have been able to answer what has happened to the ice. You should also be able to answer after the ice changed what happened next. You should also, we're getting ready to do number 3. We're going to pour the heated water into a cup and let it cool off for a while. Okay? So let me stop my screen share real quick. I'm going to grab a glass. Okay, so here's a glass from my cabinet and the hot water. And I'm going to pour this water into the glass. Okay. And we're going to let this glass sit for a while. And we're going to come back and make an observation about this glass. Is there heat being added to this water right now? Or did I take this water away from the heat? Very good. Oh, you thought that it would break? Well, I did stop. I did turn the stove off so that the water was no longer boiling. And this is a thick glass. I wouldn't try this in a thinner glass. Matter of fact, I don't want any of you trying this at all at home, especially without the supervision of a parent. Okay? All right. So we're going to come back to that in a moment. So we're just going to hold that question off to the side. You will answer it. It's just we're going to have to wait and allow that water to cool off in order for you to make that observation. Okay?
Okay, thank you.
So the next question, I'm going to share my screen again. How does the flow rate of syrup differ from the flow rate of water? Now, this is where I'm going to introduce a new vocabulary term to you called viscosity. When we use the word viscosity, we're talking about the flow rate of a liquid. Now, we talked about flow rate when we did our Unit 4 fog lab with the PVC pipe, remember? We're going to now call the flow rate of a liquid viscosity. Everyone unmute yourselves and say viscosity. And viscosity is the flow rate of a liquid, okay? So I'm getting ready to do a quick little demo and show you all the difference between this syrup. It's one of my favorite yummy syrups, and the flow rate of the water inside of this measuring cup. Okay, so I'm going to pour these substances into these two bowls, and I want you to be able to tell me the difference between the what? What's our new word? Viscosity. Oh, I see. Someone said that they did a viscosity project for the STEM fair.
I got water.
All right, now I'm going to mute you all again. Okay. And I want you to watch this part of the demo. So I'm going to try to pour these at the same time so that you all can answer your question. Okay? Here we go. Uh-oh. Okay. Should tell me what you noticed. I don't want to waste too much of my syrup because I actually use this syrup on my pancakes. All right. Now I want you to even look at what's happening inside both bowls. In one bowl, when I move the syrup around, matter of fact, if I do this, does the syrup come out of the bowl? It takes a while, right? But when I turn this bowl upside down, the water just flows right out, right? So viscosity is the thickness of a liquid, which affects its ability to flow. It's the thickness of a liquid. So which of these, the syrup or the water, has the greatest viscosity? Which one has the greatest thickness, in other words, that I'm asking? Okay, someone says syrup. Very good. Does anyone disagree with that? That it's the syrup?
Miss Hutchins, is viscosity how fast
It's the thickness of the liquid which affects its ability to flow.
Oh,
Okay, good question. Really good question.
Thank you.
Okay, anytime. Okay, so now I'm going to share my screen again so that we can look at that document together. All right, so everyone should be able to answer number 4. Now our conclusion questions. How can we change that water back to ice? Go ahead and answer that now. I'll give you a clue in a moment. And after you answer that question, we're going to talk about the different phase changes. Medina, sweet girl, can you bring me my dry erase board and some markers, please? Okay, I'm also, you all, if you see me looking away, I'm looking at another camera because I'm going to be posting this video on YouTube for the students who were unable to join us today so that they can do the assignment as well. Do you have any dry erase markers too? Okay, perfect. All right. And you may have to move the camera, that camera for me. Okay, so we're getting ready to go back. We're going to go through a lesson on phase changes. So if you want to take notes, you can. Let me clean up some of this water. What do you want? I'm going to put it behind me. All right, I'm going to put it behind me on this counter. Thank you. Okay, can everyone see the board? Yeah, no, maybe? Can you see the board? Okay, perfect. Thank you. Uh-huh.
We're doing number 3 right now, right?
No, we're in the conclusion questions now.
Oh yeah,
Remember, we have to come back to number 3 because our water, we're still waiting for it to cool off. Remember? Okay. All right. So there are 6 phase changes, although in today's lesson I've only asked you about 5. So we're going to focus on those 5, and I'll give you the 6 as a caveat, okay? And there we go. All right. So first things first, when the ice turned into water, what was that called? When the ice turned into water, what did we call that? Which phase change is that? Type your answer. Melting. Very good. Did we add heat or did we take heat away? Did we add heat? We added heat. Very good. We added heat. So I'm going to kind of color code these. Okay, very good. And remember, you're typing your answers. You're typing your answers, okay? The next thing, the water began to do what as we continue to add the heat? Type your answer. It began to boil. So now we are boiling the water, and the water became, looking for some typed answers, steam. Very good. So the water became steam. Another word for steam is vapor, which is a gas. It became vapor. Very good. And what do we call that process? When water becomes vapor. Evaporation. Very good, Nasaya. And did we have to add heat for that to happen or take heat away for that to happen? We had to add heat. Very good. Okay, now, here's where I want you to make a prediction. Here's where I want you to make a prediction. So we're no longer adding heat to this glass. I'm trying to put this glass close to the camera. There are some water droplets. Seth, this is for you. This is our number 3 or 4, I believe, where I asked the question, what happens to the hot water over time in the glass? What do you notice on that glass? Write it down. What do you see on the glass? All right, someone said condensation. That's right, condensation droplets. That's why in the morning when we wake up after sleeping at night, we see what's called the morning dew on the grass outside. The grass is kind of wet, right? Because that water vapor that was in the atmosphere, it cools and it returns to the earth. And that's the water droplets that we see on the grass and the plants, our cars, the top of your mailbox, and everything when we wake up in the morning. So yes, that is correct. That is called condensation. So let's go back to our notes. I hope you guys can see. I know my board is like far away. So when the steam or the vapor, as we call it, it's going to become what again? The steam, water, very good. And that is called condensation. I'm gonna try to bring my board closer so you all can see what I've written. Is that a little better? Not precipitation, condensation. We'll talk about the precipitation phenomenon later. Precipitation is when it rains, hails, sleets, and snows. So it's a similar concept, but a slightly different dynamic. Carolyn, where are you lost? Type your question. This is some good feedback from everyone. But can you see my notes? Samari, type your question. We're not on number 9 yet, sweetheart. Okay. Now I want you to answer what needs to happen in order for us to go from steam back to water. Do we need to add heat or remove heat? Remove is correct. No, you do not have to define those terms. You will use those terms in your answers, in your writing. I provided you with the vocabulary for that purpose. Okay? There are like 2 more phase changes that I would like to talk about with you all before I let you go today. If I wanted to turn this water into a solid, Tori, please don't use the chat room to tell us about extraneous things that's not related to the lesson. I'm going to contact your parents. And I do want you to know that Dr. Jelks is in the chat room and she sees everything that people are typing. So please refrain from doing that, Mr. Cunningham. This is serious. This is our education. All right, when I want to turn this water back into ice, very good, Nasaya, we're going to freeze it. Look at somebody being all fancy, talking about 32 degrees Fahrenheit. What would it be in Celsius? Very good, 0 degrees Celsius. Okay, so when I want to turn the water back into ice, that process is called freezing. And I'm going to ask you this question. Does that require heat or the removal of heat in order to freeze? Very good, the removal of heat. So we are going to remove heat. Okay. Now, there are 2 of those vocabulary terms on there that, hold on, one person needs to be admitted. There are 2 vocabulary terms on your lesson that are exothermic and endothermic. Exothermic means when heat is leaving a system. When heat is leaving, like exit, exothermic, you get it? Endothermic is when heat comes into a system, almost like the word enter. So Genesis, you were shaking your head no. Exo, like exit, exothermic heat leaves the system. And endothermic heat is entering a system. So let me ask you this. I want you to determine, where did heat leave? Where did we need to remove heat? Was it melting, evaporation, condensation, freezing? Which 2 of those did we lose heat in order for that phase change to happen? Someone said condensation and freezing. Very good. No need to spell it for you. It's at the top of your Google document that I shared with you all for the exothermic and endothermic, okay? All right. So yes, we did remove heat here. So this is an exothermic reaction because we had to take heat away. Heat had to exit. And this one is an exothermic reaction. And when we add heat, we're taking in heat. So those two would be considered what type of reaction? Endothermic or exothermic? Someone is saying exo? Exo means heat is leaving. We're talking about melting and evaporation. Endothermic. That's E-N-D-O thermic. And evaporation is endothermic. So I'm going to box these vocabulary words. Okay. So I'm going to bring you guys closer to the board so that you can see all that I've written. Jenna says, unmute yourself and tell me where you are confused. Hold on. Genesis only. Well, I'll unmute you. Okay, Genesis, where are you confused, honey? Right, when we're removing heat. When we're adding heat, because the ice had to absorb heat in order to become water, right? Are you looking? In order to become water, the ice had to absorb heat. So that means we added heat. It took in heat, endothermic. Kind of makes sense? Okay, very good. Can we talk about chemical and physical changes? That's coming soon, Seth. I just want to make sure that people understand the notes behind us. If anyone wants to take a screenshot of the notes, there you are. I think that's my whole board. And I will also post a picture of that board in Google Classroom as well as part of the recap for our meeting today. Okay? Deanna, you don't need to type everything that's happening, okay, at your house. Darwin, just reset, restart with your mic so that you can hear. Okay, I'm gonna do screen sharing again so that we can look at the document together. So with the conclusion questions, I believe we've answered how can we change water back to ice. And I believe we've answered which phase change took place when heat was introduced to the ice in a pot. We've answered what phase change occurred when heat was introduced to the water itself once the ice melted and became water. And then we've answered number 8, what phase change occurred when the hot water cooled when we removed heat from the system. And we've also answered what phase change will occur when the water is placed back into the 0 degrees Celsius environment. Now we're on our conclusion questions. Physical versus chemical changes. Okay, now let's suppose that Miss Hutchins placed pancake mix in the pot versus water. What if I placed pancake mix in the box? What would have happened? Who wants to answer? Let me know in the chat. Darwin, you must reset. What would happen if I placed pancake mix in this pot and heated it up versus water in this pot and heated it up? Chase? Okay, let me find you, Chase, so that I can unmute you. Okay, go ahead. Chase, can you speak now? Okay, go ahead. Answer that question.
So what would happen was, because the pancake mix has a greater viscosity,
Okay.
it wouldn't really boil, but it would more like cook.
It would cook, right? And could I make it go back to what it was before?
No.
No. But the water, when I boil it and it becomes steam, can I turn the steam back into liquid water?
Yeah.
Yes, through a cooling process. So if I can make it go back to what it originally was, then that's a physical change. If I cook the pancake mix and I can't make that go back to just being pancake mix and I have a totally new substance now, that's a chemical change. Does that make sense?
Yeah.
Okay. Okay, Tori said he knew the answer. Somebody said solid, solid, solid. I'm going to share my screen again so I can see which question we're on now. We should be almost at the end. Okay. So, let's see. Number 11, categorize each phase change that you observed today as either being endothermic or exothermic. So today, Tori, you observed melting, you observed evaporation, and you observed condensation. We didn't get a chance to observe freezing because I didn't walk you over to the freezer. But you can just about imagine what happens when we freeze water, right? Evidence of that is in this bowl. That concludes the demo for today, but not our lesson. I'll need to walk you all through additional announcements and things that you need to take care of in terms of assignments tonight. So, let's see. Okay, and then you'll answer the 2 questions at the bottom. What did you like about this demo today, and which demos would you like to see in the future? Now Samari, what are you confused about, honey? What are you confused about, Samari? Type your question. What was confusing? I'm waiting for you to type your question. All right, I'm moving on. So you'll submit this document through Google Classroom after you type it in. There you're saying so he understands, so he can hear. Thank you so much, Genesis. I really appreciate you being willing to help another classmate. And Samari, please reach out to your classmates as well, because I don't know, you haven't told me what you're confused about, so I don't know how to help you. Which 2 changes, honey? Physical and chemical changes? All of the phase changes, freezing, melting, condensation, evaporation, and there are 2 we did not talk about today, and that's okay. Those are all physical changes. If I could convert the thing that I physically changed back to its original form, then that is a physical change. A chemical change happens when I burn or I cook something or I mix it with a different chemical and it produces a totally new substance. That's a chemical change. So Samari, I hope that answered your question. I see you were still typing as I was answering you, so I hope that you got my answer. For everyone, I'm going to share my screen so that you can see some of the goodies that I've posted in Google Classroom for you. Okay, so you'll go ahead and upload this document into Google Classroom, of course, so that you can turn that in and get a good grade for being present in our Zoom. And for people who were not present, this is going to be posted as a YouTube video later on, and I'm going to put the link up in Google Classroom for our friends who were unable to be part of our Zoom meeting today. Another assignment that you have, open Google Classroom so that you can follow along with me. It's going to be the kinetic molecular theory, the behavior of gases, of particles, of matter. So I have this assignment open. I'm going to view the entire assignment, pulling up the instructions. And it reads, scholars, you will complete each step 1 through 4 in the student directions for understanding. Anytime you see KMT, that stands for kinetic molecular theory. So you will be writing in this document. That's where you're going to record your answers using the gas properties PhET simulations. Then you will complete steps 5 through 6 using the states of matter PhET simulation. Be sure to answer all parts of the question on the student direction sheet and remember to submit the assignments when completed. So I'm going to open that document right now. I'd like for you to open that document right now as well. And here are the learning goals. Here are the questions and things that you have to do once you open the PhET simulations. Now, all 6 of these questions are pertaining to these 2 PhET simulations. You have a gas properties and you have a states of matter. I'm going to open the states of matter simulation for you now. When it opens, you can play with it here or you can download it. So I'm going to download it. And in the bottom of my screen, let me open my screen back up. I don't know what happened. Everyone in my house is online, so it's making this kind of frustrating because I lose my internet. Okay, so I can imagine a lot of you must be going through the same thing. So I'm going to download the PhET simulator. Oh, it did it again. Oh my goodness. You know what? I'm thinking it's because I'm on a Zoom meeting with you all. But anyway, you're going to open this when we're no longer on Zoom. And you're following the instructions inside of this document in order to do the virtual lab. And then there's a second lab called gas properties right here. You're also using this simulation depending on the questions you're asked. So questions 1 through 4 require you to use the gas properties PhET simulation. And the remaining questions 5 through 6 require you to use the states of matter simulation. Okay? So I'm going to stop the screen share so I can see what your questions are. Uh-oh. Where'd my meeting go? There we are. Your reactions get me every time. It didn't come up for me. It will as soon as we are no longer on the Zoom meeting because mine didn't come up for me either. It kept knocking me off the thing here. Okay. So I'm trying to see everyone's questions. Can you help me understand? Okay, I don't know what Carolyn is saying. So we only do 1 through 4. No, you will do all of those questions, Darwin. All of them. You have the PhET simulation for both of those. Naomi said, what if we didn't finish? You have until 5 p.m. to finish. You have until 5 p.m. to finish. Good, good. I see your question. What time are they due? It's on Google Classroom. I'll put the due dates in on Google Classroom. May you please explain question 2. All right, at this point, I'm going to allow you all to work with your classmates because time is of the essence. So you can work online with your classmates because we went through question 2, I believe, already. What are we doing next meeting? I will send that out. Check your notifications for Google Classroom. I will send that out, what we're doing for the next class session. We meet again on Friday. Today is Wednesday. We meet again on Friday. Oh, thank you. Somebody just reminded me. Flipgrid. Let me share the screen once again so that I can let you know about the Flipgrid. So, this is our Flipgrid. I'm so psyched about this. All right. So I'm going to refresh the screen. So many people have posted already. Yay, look at this. All right, Layla, big shout out to Layla Hawkins. She was the first person to post her Flipgrid, followed by Jonathan. Then Khalil, Samari, Marvin, Seth, Kennedy, John, Armand, John H did 2. You are please only submit 1. If you submit 2, that's gonna just submit 1, please. There's no need to submit 2. So I'm gonna delete 1. And I'm gonna be a little irritated if you submit more than 1. Lillian, and then Ian, Nia, good job. So make sure you do your Flipgrid. I emailed you all the link, and the link is posted in Google Classroom for the Flipgrid, okay? We have 2 minutes remaining, so at this time, I'm gonna look at questions, and people, let's keep the question, like if it's something that another classmate can answer, then I'm going to ask that you ask your classmates through Google Classroom. If it's definitely a teacher question, then I can answer it right now. But time is of the essence. Time is of the essence. And I want you all to have this 1 hour access to me to answer like teacher questions. But if it's a question that you can ask a classmate, I want you all to build that sense of camaraderie among each other and feel, comfortable asking each other questions and answering each other. Some of us are being a little rude to each other in answering questions. So I want us to not do that. I want us to be polite in how we are answering questions. For the multiple choice questions, are we supposed to answer them? I'm not sure what you're talking about, Ava. So email me that independently. What assignment are you referring to? Fog is due soon, but anything I need to know about the Fog project that is new? No, I think I've already covered it. Go back and reread messages in Google Classroom. Can you post a review? Always, always. I always do. And actually, I won't even have to post the written part. Maybe the assignments, yes, to recap. But I'm filming this on my iPad as I'm talking with you all. So the video will be up as well. Student direction for understanding KMT. Very good. The Flipgrid is the QR thing. Yes, it is. I gave you both. We can email. Yes, we can. Oh, that's good, Sanaya. Good. You reminded me. We got 1 minute left. All of my people that's doing the engineering grease trap, we have our own Zoom meeting that I will send out to you. But I need you, yes, each section hosts can each section host their own Zoom meeting? No. I'm not set up for that. You have to pay like $176 a year to do different sections. So I'm sorry, Samara. I mean, a girl loves to buy purses and shoes, but I just can't spend $176 on a free app. The Zoom meeting for engineering people, Friday, 1 p.m., engineering people only. You don't need a partner for the engineering thing. All right, so we're going to have our own meeting Friday at 1 p.m. All my engineering people, you need to email me so that I can know who's doing the engineering project. If you do not email me, then I will not send you the invitation for Friday Zoom meeting at 1 p.m. Okay? All right, guys. Well, we're actually 1 minute over the time. Everybody unmute and say bye. Oh, wait, you can't unmute because I didn't allow you all to do it. Okay, there we go. Bye.
I have a question real quick.
Hey, Miss Hutchins, I have a question. Miss Hutchins.
You got to email me the question.
Email.
We're going to start and end all meetings on time. Bye.